We're going to look at the molecular geometry here of NH₄+. This is the ammonium ion. So when you look at molecular geometry, the first thing is you need a valid Lewis structure. If you need help, link in the description at the end of this video as well, how to draw the Lewis structure for NH₄+. So we have our structure here, and what we can see is we have 1, 2, 3, 4 bonds. So we have 4 bonds to the hydrogen atoms. And the plus out here in the brackets, that just tells us that we have an ion. So we can kind of ignore that when we're looking at molecular geometry. So remember, we have the central atom, the nitrogen, with the 4 hydrogens there, single bonds, and no lone pairs. So you can imagine these hydrogen atoms all spreading out around that central nitrogen. And that looks like this. This represents the central nitrogen. I'm going to add 4 hydrogens. 1, 2. You can see they push away from each other, so they're on opposite sides. That would be linear. 3, that's trigonal planar, but we have 1 more hydrogen right there. It pushes everything down, and we end up with a tetrahedral molecular geometry. The electron geometry is also tetrahedral because there's no lone pairs. If we looked at the ideal bond angles, they would be about 109.5. That would be the ideal for the tetrahedral molecular geometry. Let's go back to our Lewis structure. So when you have 4 things bonded to the central atom, no lone pairs, that's a tetrahedral molecular geometry. If you're using the AXE notation, A is the central atom, that's the nitrogen. We have 4 things bonded to it with 0 lone pairs. So we could just get rid of the end here, and we'd have AX4. If you look that up, AX4, that is tetrahedral. So that's a molecular geometry for NH₄+. It's tetrahedral. It's Dr. B. Thanks for watching.